Hi, I'm Chris from SQL4automation. Today we're going to make an application which will measure the temperature and humidity in a room every 5 seconds and store it in a database. To get the data, we're going to use this EE10 M1A3 sensor and hook it up to our Siemens S7 PLC. The PLC will then process this data and send it to our SQL4automation Connector, which is running on an NUC. And the connector will then finally transfer this data to a MariaDB database on a Synology drive. Now this video is a little bit longer than usual, but you can always skip around using these timestamps here. As a first step, we're going to create our project. Now I'm using the TIA Portal version 15 on this Windows 10 computer, so I'm just going to open it and create a new project. And then I'm going to name it, and I'm going to put it into my project folder, which I have here. Click Create, and open the project view. Okay, so first of all, we're going to need a device. Now, by looking at the front plate of my PLC, I can see its type. So I'm just going to search for that in this list here and add it. So to use the PLC, I first have to configure it. And in my setup, I'm going to have 5 main devices, which are all connected to each other in a network. Now, it doesn't really matter what address they have as long as they're in the same subnet. But I think it's easier afterwards if you know beforehand what IPs your devices will have. So instead of using DHCP, I'm going to assign this IP to my PLC. First, I'm going to double click on the port I'm connecting to, and the port will be this one. And then I can go down here and enter the IP in the project. Next, I also need to assign this IP to the PLC itself. So I need to connect myself to it, and I'm going to do that using this online access function down here. And then under the network adapter we are using, we can search for all the accessible devices. But before my PLC can be accessible, it has to be connected to my network. So I guess it's possible somehow to do this via the router, but the easiest way is to just put an Ethernet cable between your computer and your PLC. And because I want the computer to be in the same subnet, I'm just going to change its IP real quick. Alright, so now we can search the PLC, and there it is. Now I've already used this PLC in a previous project, and it already has the IP I wanted to have. Either way, to assign an address, you would have to go in here, Functions, Assign IP Address, type in your address, and click Assign IP Address. Now, if like in my case, you've already assigned some IP to the PLC, this won't work. In that case, you first have to go to Online and Diagnostics, then under Functions, Reset to Factory Settings, and select Delete IP Address. Alright, so let's hook up our sensor now. In this project, I'm going to be using this sensor here. Now, the sensor needs to be powered with 24 volts, and it's going to give us back 2 output voltages ranging from 0 to 10 volts. One for the temperature and one for the humidity. Which means in total, we're going to need 4 cables. So to connect it, I'm going to connect the humidity sensor to my analog input 0, the temperature sensor to the analog input 1, the ground to the common ground next to it, and then finally the hot wire to the 24 volt output. Next, I need to find these inputs in my project. To do this, I'm going to go down to my device configuration, double click my PLC, and then down here under analog inputs I can find my 2 channels. So the first channel has the address IW64 and the second IW66. So now I'm going to create 2 tags for these inputs. I go to PLC tags, default tag table, and add 1 tag for each of them. And in here it's obviously important that we know which sensor is going to which channel. And in my case the humidity is on the first and the temperature on the second. Alright, now when we have that, we can click on Monitor, which will bring up this window because it's our first time connecting. And there we just search for our device, which is directly connected via the Ethernet cable, and click Go Online. And can you believe it, we already see some values. Now, they don't really make a lot of sense now because they're in hex, but when we convert them using a calculator, for example, we can see that we have a humidity of 13,174% and a temperature of 12,438 degrees Celsius. Maybe I should open a window. No, of course we have to convert it first. To process this data, we're going to create a program. So first I'm going to go to Program Blocks, delete this existing block, create a new organization block, OB main in the one and only language, SQL. Okay. Now, like I've mentioned before, we have a temperature sensor which will take 24 volts from the PLC and give us back a voltage which depends on the temperature around it. So in the end we're only really interested in this temperature value. But in order to get there, like in many other things, we're first going to have to take a few steps. First, we have our sensor, which will change its inner resistance based on the temperature around it and give us back a voltage from 0 to 10 volts. And the temperature of 25 degrees Celsius will give us a voltage of 5 volts. Now, why that? If we have a look at our manual, we can see the range of our temperature sensor, which goes from 0 to 50 degrees. So it makes sense that the middle of our voltage range is also the middle of our measuring range. At the next step we have our input, which will convert this voltage into a data word. Now our data word has a range from 0 to 27,648, and because we're in the middle, we should have 13,824. But why this range? To explain this, I'm going to have to go a little bit deeper. First, let's take a look at our PLC manual. If we go to page 799, we can find the measurement ranges of the analog inputs for voltage. And if we only take a look at the range from 0 to 10 volts, we can see our decimal range. But where does this total range come from? Now, you probably know that one data word consists of 2 bytes, and 2 bytes consist of 16 bits. So if we put this number in our calculator and calculate 2 to the power of 16, we get a total number of possible values we can represent in a word. And because we also want to have negative numbers, we can divide it by 2, which will give us the upper and lower limit, not including 0. Okay, so now in our program, we're going to take that word and normalize it, which means we're going to bring it into a range from 0 to 1, which will give us a value of 0.5. And then finally, as our last step, we're going to scale this number, and by scaling, we're going to bring this value back to the range of our sensor, which goes from 0 to 50. So we should get our 25 degrees again. Okay, so to do this, we're going to use 2 functions. If we go to basic instructions, conversion operations, we should find the norm function and the scale function. So let's start with the norm function. Now in here I'm going to have to enter my range, which starts at 0, one of our tags as the value, and the upper limit. And the function will then give me back our normalized value, which I'm going to store in a variable. Now I'm actually making 2 small mistakes here, but we're going to get to those later. So let me just do the same thing real quick for my other input, and we can test it. Since I haven't compiled the hardware yet, I'm going to do that real quick. I'm not sure if it's necessary. And then I'm going to upload the hardware configuration. And after that we can compile our software. And we should see the first error I talked about. Now the error has to do with the data type we get from our normalize function. I've assigned it to a word, but it's actually a double integer. Which brings me to my second error. I'm assigning it to a real value here, which for some reason seems to work. But later in the video we can see why it's not ideal. Anyway, let's compile it again, and we can download the software. Stop any existing program. Go online, and then monitor the values, and we should see our normalized measurement. Okay, now we want to scale this. To do it, I'm going to drag in this scale function, and just like before, enter the range I need. Now each sensor has its own, so let's open the manual, and at the humidity sensor we can see the range from 0 to 100. So let's put that in, assign our normalized value, store it in a variable, and then do the same thing for our temperature. So now we just need to create the new variables, compile the change and upload it. If we now monitor the values, we should see our humidity, which is 48%, and the temperature, which is 22 degrees, which looks about right. Okay, so now just to clean it up a bit, I'm going to insert a normalize function into the scaling function, which I think looks a bit nicer and saves us 2 variables. And that's it. So now we have an application which will get us data using a sensor and then process this data in a PLC. But we're not finished yet. We want to give this data to our connector service, which runs on the NUC, and then from there transfer it into the database, which runs on my Synology drive. So before I can do this, I'm going to change my current network and connect the PLC back to my router. To transfer the data to our connector, we're going to use the SQL4automation library and an example project, which I've both downloaded from our website. And then to import the project, I'm going to open it as a reference project. So I just go down here, open the reference project and search for my folder. Now I could open it from here, but I'm first going to copy it over to my project folder. Alright, now I just open it and let it upgrade. Alright, so here's our project, which we can open. And then I'm going to select the blocks we need for the connection, and the first example to use is a template. And I can just drag this into my other project. Then I'm going to do the same with the corresponding data types and the watch tables. And that's all we need. So now we can close this down and have a look at our program. First of all, I'm only going to need to call one custom function block for my main block. So I just copy that with the header and paste it into my other block. And then I need to make sure that I process the data before I call the block. Alright, so I can delete the old one. Then next I want to make a function block for my insert query. So to do this, I'm going to create a new group called data logger and use the insert query as a template. Just going to rename it, which automatically renames the call, and delete the other queries. And then in my function, again, because I only have one query, delete the other 3 function block calls. Let's take a look at our function block now. In the block, we're basically going to take our data and put it into an SQL string, and this string will then be sent to the connector. So let me just make some space. This block contains a state machine which starts in an active state, and as soon as it gets executed, it creates the request string and starts the transfer. After that, it parses the response, resets, and goes back to the start. So as you can see in our second step, this example also inserts some data into a table, just like we want to do it. But we're not at that point just yet, so let's comment it out first. So before we can send the data in our block, we first have to give it to him. And we're going to do this with a structure. So first I'm going to rename it. And then instead of these values, I want to assign the humidity and the temperature. Next, in our function block, I'm also going to rename it. And finally, because I can't compile it like this, because we get an error, I'm going to go to my data block, right-click, and update the interface. Okay, so our next step would be to create the insert query, but we can't really do that now because we haven't really decided on the table name, the columns, the database itself, etc. So let's set up our database first. To store the data, I'm going to be using a MariaDB database on a Synology drive. Now I'm not going to show you exactly how I installed it because I already did it and I think you just have to press a button. But the 2 applications I'm using are MariaDB and PHP MyAdmin, which you should find in the package center. After installing, you can click on this link to get to the PHP MyAdmin web interface, and on a new installation you can just log in using the username root and no password. Now after logging in, you should see something like this, and as a first step we're going to create a new user for the application. Just click Users, and then add User, type in a username and a password, and then we have to assign the privileges. Now I'm not an expert in this, so this may not be the best practice, but I'm just going to select a few I think could be useful, and click Go. Next we're going to create the database. Go to Databases, type in a name, and click Create. And just like that, we've created the database. So as a last step, we need to create a table. And we could also do this in here, but I'm actually going to use a different app for it, because with the app, it's afterwards easier to make changes to the database. Now the app is called Heidi SQL and you can download it for free on the internet. So first I'm going to open it, create a new session, give it a name, select MySQL for the protocol, enter the IP of our Synology drive, the user and password, select the default port, and we should be able to select our database. Alright. After opening, we can right-click our database, create new, and select table. And then in here I'm going to give it a new name, click on add, and add 4 columns. Now my first column will be my ID. I'm going to define it as an integer, make it unsigned because I don't want negative IDs, and unselect this, which doesn't matter actually. Then I right-click, create new index, and set it as primary. Now this will make this column my primary column, and it will make sure that later each entry in the database can be uniquely identified by its ID. Next will be my entity, which I'm going to assign as a varchar with the length 50, and then the state, which will contain our measurements, so we're going to make it a float, and then finally the timestamp, so we know when the measurement was done. And I'm not going to allow null values in any of these. Alright, so now we can save this, and we should get an empty table. And just one setting I forgot, I want to set my ID column to auto increment. And this way it automatically assigns unique IDs to new rows, incremented by 1 from the last one. And that's it. So let's connect our connector to it. In this video I'm not going to show you how you can install the connector, because I just did it in the previous video, but you can click on this link if you want to watch it. So on my laptop, I'm starting the config tool and connect it to my connector service on the NUC. And because the NUC and laptop are connected to each other in this network, I have to enter this IP as my host. So let's enter it, press OK, select it and connect. Next I'm going to create a new link. Give it a name, and as our target select the Siemens PLC. The IP I'm going to leave blank for now. Then the connector I assign to my NUC with the default port. And finally my data source to my Synology drive. Now to create a new source, we can go to db-admin. Now I've already created the source earlier, but if you're creating a new one, you just click add and then select the type and enter the server, the database, and the user and the password, and click OK. Hit refresh and select the source. So now we just need to enter our login again, click OK, and that's it. And if your LED happens to be purple, you can just activate a test license and it should work. Alright, so now we can test the connection. To do this, I'm going to open the query tool, connect it to my connector service, and write my first query. So I want to insert into my states table the values null for my ID, the string test for my entity, some value for the state, and the function now as my timestamp. So let's just check that real quick. The ID is a null, the entity a string, the state a float, and the timestamp a timestamp. Okay, so let's send it and go to our database, select data, and we should see our entry. Great, so our connection seems to work. So what now? We've laid all the groundwork, so now we should be able to bring everything together. And we're going to start with the insert query. Now, instead of developing it in here, I'm going to set it up first in the query tool, because that way we can test it a lot faster. So let's open it. And then instead of this, I want to insert my temperature. And because I also want to insert the humidity, I'm just going to duplicate it and put it afterwards. Just change the values here. Yeah, and then we can test it out. It seemed to work, so let's look at the data. And it's just the way I wanted it. So let me just reset the database. Copy this and insert it into a notepad. Our task now is to separate this string into substrings, so we can then dynamically insert the measurements as our values. So let me just split it up around them. And I'm going to make this to a string and change the values to my variables. Now in Siemens we actually have to use single quotes, which is why we have to escape the ones inside the string with a $sign. because if we don't do this, our program won't know where the string starts and where it ends. But depending on the database, you could probably also change the inner quotes to double quotes. So that's what we're going to have to insert into our PLC. So let's go there. Now the first element will be the insert command, so let's paste it in. And next we'll have our measurement, which will convert from a real to a string. And then comes another string, and so on. It should be pretty straightforward, so we're just going to add these substrings one by one. Alright, so now we have our query. But in order to transfer the data, our function block first has to get the data. So we're going to give it to him from the main block and assign the measurements to its data block. Okay, so let's test it. Compile and upload. And then I'm going to create a watch table using the insert example as a template. Call it data logger and change these to my measurements. So now we can go online. We see that our logger is ready, and we can execute it. Alright, so as you can see, we got an error. And that's because in our link settings, we allowed our service to assign the first device which connected to it as its target. So this means it's probably assigned to the NSA or some Chinese hacker now. Or maybe our laptop from before. Anyway, to fix this, I'm just going to reset it. I could also directly enter the IP of my PLC. And then execute it again. And it worked. So in our database, you can now see the temperature and the humidity. But if you look closely, you can see there's a small problem. As you can see here, our measurements are rounded, so we're losing quite a bit of precision. And it's because of the second mistake I made earlier. I'm actually using the wrong conversion functions. What we want are real values, so we have to write this, because otherwise it will just give us a double integer. So let me just do that real quick. Re-upload it, and try again. Alright, that looks better. But now it's actually a bit too precise, because our sensors aren't that good. So maybe let's take a look at the datasheet. Our humidity sensor has a precision of ±2%, and our temperature sensor ±0.25 degrees. So for simplicity, let's just round our numbers to one digit. Instead of using the PLC to round it, I'm just going to make the database do it. So we can just add a round function to my insert string, and it should work. So if we now try this again, we should have our values rounded to one digit. Alright, so that's pretty much it. The only thing we'll have to do now is execute this function block every 5 seconds. And to do this, we're going to use a timer function. So we can go to basic instructions, open the timer operations, and select the ton function. Then just give it a name. So now as an input, we're going to use the output of the timer. And this way it will always automatically restart itself after it's finished. And then as the duration, we're going to set 5 seconds and press enter. And then always while our timer is running, we're going to execute our insert function. So it will always be active for 5 seconds, then stop between the timer cycles and restart again. So let's upload this and it should start logging. Alright, so now we have an application which will measure the temperature and humidity every 5 seconds and put it in this database. And that's about it for this video. Let me just clean up this code a bit. and then we can let it gather some data for a while. In our next video, I'm going to show you how you can visualize this data using Grafana. So if you don't want to miss that, subscribe to our channel, and if you have any questions or comments, feel free to write them in the comments below. Thanks a lot for watching, I hope this video was helpful, and I'll see you in the next tutorial.